Hello everyone, I'm Thomas and this is day 9 of 100 Days of Code in IoT Challenge. As I promised yesterday, today we're going to secure the request that we're making, and instead of local server, we're going to make it to the internet hosted web service that we're also going to create using Golang, Serverless, and AWS Lambda. That's going to be actually put behind API gateway. Okay, let's move to the code. There's not really going to be any new parts or components today, just the code. Okay, so before I move to the code, let me just quickly go through these slides. So we have a list of requirements and the steps that I'm gonna do today. Hopefully today, because I might need to split it into 2 videos, but yeah, let's see how it goes. Right, and for the requirements, I'm not gonna be installing them in this video. So if you want to follow my steps and replicate it on your machine, you have to install everything on your own. Links to the instructions how to install those things and set everything up are in the description of the video. However, if you get into some issues or something like that, leave the comment and I'm going to make a video how to install everything. So yeah, no worries. Right. So yeah, what is required to start? We need AWS account, AWS command line interface set up with everything required by AWS. I think Python is among the requirements. Then Go installed locally, serverless, that can be done through npm package manager, and either Mozilla Firefox browser or OpenSSL. That is going to be needed for extracting certificate. Easier way is through Mozilla Firefox, but yeah, I'm going to also show how to do it using OpenSSL. And for the things to do, we have create serverless API. So essentially, I'm going to replicate the same functionality as I have done with the web service yesterday that I hosted locally. Then we need to retrieve a root CA certificate that's needed for SSL for the bare SSL client on ESP8266 site. Right, so this is to avoid man-in-the-middle attacks, right? Securing the web request. This is the part about security. And then the last step is going to be compile, deploy, and test. Right, so that was for the slides. Now I can move to the code. So let me just do that. I'm gonna close the presentation. Okay, so that's what we built yesterday. That we're going to modify later on because we're gonna start from serverless part. However, for serverless, we need a new project. So I'm going to go to the terminal and go one level up in the directory structure, in the directory tree, to the projects. And here, because I've got serverless installed, so this is the requirement here. I'm going to create the Go service, AWS Go mod. This is the name of the template that is going to be used for serverless. So that's the command, and that needs to be done from the project directory level because it creates a directory with the name specified here. So my directory is gonna be called hello from IoT app. Okay, so that was quick. So now we've got this directory here, hello from IoT API. And on this project, I'm going to go back to hello world 123 and open the new window in Visual Studio Code, where I'm gonna open the folder with the server service. Okay, so now let me just quickly go through the configuration files first. We have serverless YAML. This is where we define all the infrastructure. Most of the stuff is already done for us. Let me just quickly go through it. So service is the name of the service. Then framework version is the version of the serverless framework. Provider AWS, runtime Go 1.x, so any Go with the major version of 1. Then you can specify region on AWS if you use different than US East 1. Role statements, these are required for using stuff like DynamoDB or S3. We're not using them, so I don't need to specify anything here. Then package. For Go, only the bin directory is required, so the binaries. And functions. This is where the Lambda functions are defined. We don't need 2 Lambda functions, so I'm gonna keep hello only. I'm removing world. And also I'm going to change the event to HTTP. HTTP API is a new one. I don't know much about it yet. So yeah, I need to find out. So yeah, I'm just gonna use the REST API one. Path, I'm gonna keep hello. However, method, we want to have post, like we had yesterday. This is the path to the binary directory, to the handler. There is no binary directory here yet, but I'm going to create it in a second. Is there anything to show you here? No, this is it. Yeah, we don't need anything else for that project. Then I'm going to open makefile because I need to modify it. We don't have world anymore, so I'm removing this line from here. And you can also have a look and see what are possible commands that you can run with makefile. So we got build. This is to build the binary, clean, deploy. That's the command we're gonna use to deploy to AWS. And we have go mode gen. That is, I think this is used with build. Yeah. Okay. The world folder is also redundant now. So I'm gonna remove it. We just keep hello. Is there anything I need to show you? No, we can now open the main.go file. This is a template code. It uses a basic Lambda function, so it takes a context as an argument, and that is something I have to change. So I'm gonna define a new type. It's more like an alias for the type. I'm gonna call it request, and this is essentially API Gateway Proxy request, because now we know we're using REST API behind API Gateway, so we can take this request as an argument. Essentially, I'm gonna do pointer to request, and also I'm gonna respond with pointer to response. So need to take address instead here, and also here. Another thing I'm gonna just quickly modify is to move this there, because I don't see a point in creating a variable just for returning it, the line after. Okay, let me just quickly explain what happens in this code. So everything starts from the main function, as like in every Golang application, and it uses the Lambda package and run start method with the handler, which is this function. This happens every time the API Gateway endpoint is requested. And what we're going to get here is our request, which is API Gateway Proxy request. There is a bunch of metadata there, along with HTTP method, headers, path, body as well. This is something we're going to add in a second. And on the response side, it also requires a specific type of structure, accepted by AWS, and this is API Gateway Proxy response. Few fields required there. Among them is status code, headers, and body that needs to be string. What happens in the handler? We've got buffer declared. Then there is this map being created that has a type of string to interface, but essentially it's string to string in this case. And that map is transformed into JSON as a byte array. If the transformation fails, we respond with 404. If not, we escaping HTML on the JSON, and then we respond with this JSON. It is the buffer that is actually in the HTML escape. This body gets transferred into buffer with the HTML escaped, and then here we pass it as a string. So the byte is changed into the buffer is changed into string. 2 headers responded here. And I'm going to replicate the functionality from yesterday. I need to add a log, print ln, and the argument here are actually not print ln, it's going to be printf. Let's do exactly the same like yesterday. So body, and the argument with what the flag is going to be replaced is going to be r.body. So we don't need to use IOUtil to read the body, because this is being done automatically by AWS. And yeah, this is essentially it for the code. I'm going to deploy it now, so I need a terminal window. And given that you've got everything installed on your machine, I mean AWS CLI and the environment variables for AWS, it should just work straight away. So you don't need to specify any environment variables here to deploy. What is needed is make deploy. However, I'm going to do make build first, just to show you that make build creates a bin directory with the binary for hello that is used as a handler in here. Okay. Now I'm going to do make deploy, and the service will be deployed to AWS. Everything is going to be created automatically by our serverless framework. So yeah, that makes it super easy for us to do, because like doing everything through point and click in AWS, it is some work. It's not much, but still some work. And we're saving lots of time right now with serverless framework. Okay, so the service is deployed. It shows us the URL here, endpoints, post, and that's the URL to API gateway with the endpoint to the hello endpoint. Essentially, it requires post. We didn't specify get here, so it's only post. Get is not gonna work. Right, let me just quickly test that. So I'm gonna copy it. I'm gonna use curl with post. No data at the moment, and let's see what we get back. Great, we got a message, go serverless v1, your function executed successfully. And this is the message that we sent. It's this one. Okay, let me just confirm if this got printed out. In order to do that, I need to go to API Gateway on AWS console. API Gateway. Make sure the region covers the one specified in serverless YAM file. And here is our API. So I'm just gonna click on it, and we can see the endpoint, it's post, and on the right, there is the Lambda that it points to. I just clicked on it, gonna go to monitoring, and then view logs in CloudWatch to see what the Lambda function printed out during the call from the curl. It's this log stream, and yeah, we can see a body with nothing, which is correct because I didn't send anything. I'm just going to verify if it sends, if it's going to log the data that I'm going to send. So a simple JSON message, just going to be message hello. Okay, executed successfully, and I'm going to refresh here a few times. Yes, it is here. We see body MSG hello. So that part is working well. The whole step for the serverless is finished. Now I'm gonna have to extract the certificate that is needed for the HTTP client on ESP. There are two ways the PEM certificate can be extracted, and I'm gonna show you both. The simplest one is using Firefox browser. What you're gonna need to do that is first the URL. If we do it with Firefox, it's better to actually get the full URL. We don't need endpoint, just that URL. It can be with endpoint, doesn't really matter. The point is to go and visit it here. We don't worry about this message. What we worry about is this padlock button in here, then the arrow, and more information. In the new window, we want to click on View Certificate. Then we can close this window. And we're interested in the right-hand side tab, which is Amazon Roots CA1. And if you scroll down, you can find the PEM certificate. And this is the one we need. So I'm just going to download it, just saving it, and okay. So that's gonna download it for me. With that certificate, you can essentially configure bare SSL client on ESP to talk to the API gateway endpoint. The other option is to use OpenSSL using the command line. So I'm going to switch to the code. We can just go here to the PlatformIO project, and the command that we need to use is OpenSSL S client connect, and then we need this part of the URL, which is the host. I'm going to paste it here. And we need to specify port as well. Then we need host name, server name. It is exactly the same. And then show certificates. And I'm going to verify also. That command is going to give us, the thing with this one is I'm going to have to close this, stop this process after that. And here we're going to get the whole certificate chain. And the certificate I'm interested in, I think it is the last one. Sorry, this one is the last one. Sorry, no, we need the root CA1. So it's going to be the second one here. So we can just use this certificate if we want to. Anyway, I've got it already downloaded using Firefox, so I'm going to use the other certificate instead. And this is it for today, unfortunately. I'm gonna do the coding part on ESP8266 tomorrow. Thanks for today. If you are interested in this type of content, subscribe to my channel. If you have questions, feedback, or suggestions, leave the comment. Cheers, bye.